Okay, so I'm going to talk just a minute about our distillation process we've been working on. You guys have been using aluminum cans and tin cans. What I have going here is an actual water distillation device. Okay, it's called a distillation apparatus. Most of you saw this during class. I'm going to talk about how that works. I'm going to talk about changes in state of matter to help you guys out with studying with the study guide and with your states of matter and stuff. So, first of all, we've been working on our distillation process where you guys took a tin can and we tested both of these to see which heated up faster. And we found that the tin can heated up faster because it has a lower specific heat. That means this can takes a lower amount of energy to make it get hot. So we knew that this one would heat up faster. So most of you chose this one to boil the water. So that's the same thing that's going on right here. What we can see here, this is called a boiling flask. And you guys used a hot plate, but instead of using a hot plate, I'm actually using a little burner. Okay? So this burner is heating up my solution of dirty water. Again, a solution is something where it's made out of different particles and they're evenly spaced. They're evenly separated. So my burner is heating up my solution of dirty water. Just like in here, your hot plate heated up a solution of salt water. Okay? At that point, and you can't see it because it's a gas, but you can see that this liquid is boiling. It's bubbling up. So it has hit its boiling point. Alright? And this liquid's made out of several different particles. But up here, I've just used two different colors to represent the different particles. So we can see that this is boiling. So something has reached its boiling point, which is where something goes from being a liquid to being a gas. So we add heat, we add energy to a liquid, and it boils or evaporates. Okay? So right here we see some boiling going on, and that means that this liquid is turning into a gas and evaporating up into my apparatus here. Okay? So now some of my particles have reached their boiling point. So the water particles are boiling up into here. But these other particles, these whatever they might be dirt, they might be salt, whatever it is, their boiling point is much higher. So they're going to stay inside the boiling flask. So you can see in my picture here that the green water particles are evaporating into a gas, but it's leaving behind all these other particles because they don't boil at such a low temperature. So I have a gas coming through here, and we can't really see it much because it's a gas, right? Water vapor is a type of gas. You can see it occasionally when it'll push a piece of water or something. That's the only way we can really tell there's a gas in there. But as the gas moves up, comes through here, it enters this big long coil. Alright, and this is my condenser. So most of you had some kind of tube. You either used a PVC pipe or a vinyl tube for your condenser. And you saw over here, you saw a lot of vapor, and as it got farther, you saw bigger drops of water. That means this water is a gas, right? We have a gas state of water. But as it got farther away from the heat, it cooled down and it turned back into a liquid, which is called condensing. So this is called a condenser. I've taken my liquid, I've boiled it into a gas. The gas is moving through here, and then as it goes through here, I'm trying to condense it back into a liquid. So when we go from a gas to a liquid, that's called condensing. Okay, we take all this gas, we condense it down to a liquid. So again, most of you had that coming through some sort of tube and going into your aluminum can. And the cooler we can get this vapor, the more of it is going to turn back into a liquid. And if we're trying to survive on a desert island, we have to have water. We can't breathe water vapor, right? So we have to condense it back into a liquid. Now, at this point, if I continued to cool down that liquid so much that those particles stopped moving almost altogether, okay? Here they're a liquid, they're moving a little bit, but when they get to be a solid, the particles don't move very much. So if I continued to cool down my water after it became a liquid, if I put this in the freezer for a little while, then it would freeze into a solid, or what we call ice. Alright, and we talked about this being, all these are physical changes because we're only changing what it looks like. We're not changing the actual particles. Okay, we're just changing what they're doing. Right here, these particles are sitting tight. They're huddling together. It's cold. They don't want to move much. We talked about when you and your friends are outside and it's 20 degrees, you stand pretty close together. Okay, that's what solid particles are doing. They're standing close together. They're not moving much. Now, if I added some heat from solid, it would melt back to a liquid. Alright, so we've got our major physical changes, the ones that you see on an everyday basis. We see melting, especially now when you wake up in the morning and there's frost on your grass and on mom and dad's cars or the bus. That frost is solid ice, okay, little tiny pieces. And as the sun comes up, that frost melts into a liquid. That's why if you walk through the grass after it's been frosty, your shoes are going to get wet because that solid water has melted into a liquid. Okay? Then if it got really hot, you might be able to look outside on the grass and see some steam coming up, and that would be those same particles boiling into water vapor. Okay, now there's two other states that we haven't talked about, or two other changes that we haven't talked about much. Sometimes there's such a huge temperature change that a solid skips the liquid stage. Sometimes it goes straight to a gas. This is called sublimation. Okay? And there's even fewer times, you rarely see this. It's kind of a hard thing to see, but it does happen sometimes, where something goes from a gas and we take away so much energy that it goes straight to a solid. Okay, this is something called deposition. And you don't see it very often, but it does happen sometimes. Okay, so here's our three states of matter. Here's our physical changes. When we add, so these red arrows are when we add energy. We melt, we boil, we sublimate. The blue arrows are when we take away energy and slow down those particles. We condense a gas to a liquid. We freeze. We freeze a liquid to a solid. Okay? We deposit a gas to a solid. So the blue is where we take away energy. So again, here's our cool distillation device. We start off with muddy, gross water. Comes up here as a gas. It goes through the condenser. And what started as this water that you would never, ever, 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 ever want to drink becomes this nice, fresh, crystal clear, delicious water. And it tastes fine.